tape. Is that not helpful?
It might.
It's not gonna work? All right, Andrew, can you grab the lights for us, please? All right, guys, let's talk agenda first. Thing number one today is we need to start with our common assessment review. So you should have your quarterly based standards test out and a separate sheet of paper. This could be either lined notebook paper that you have, or if you find it in the bins in front of you, there should be a couple of extra sheets for you. Oh, that's right. She said that ESP was down, right? So, okay. Okay, I'm going to have to make Christina go away because she's annoying the heck out of me right now. Okay. So we got our quarterly based standards test over here. Take a look at number one. Jeffrey, what's going on in number one? Read that out for us, please. Yep. So we need to estimate when y is 60. Look at the chart, Gerardo. Just off the top of your head, if x is 60, that happens right here. What two numbers do we have to be between if x is 60? Yeah, 60 is going to be in there. I'm talking on the y side. David, help him out. What two numbers do we have to be between here? Yeah, we have to be between 93 and 118. So I can look at some of my answers. Yes, they're all between 93 and 118. So I am going to have to get into this a little bit. Vivian, what do you think a next strategy would be? That's okay. Do you think we should be closer to, is 60 closer to 56 or is 60 closer to 70? 60 is closer to 70 than it is to 56. True or false? False. So which number should we be closer to, 56 or 70? Yeah, we should be closer to 56, and that's like on the 93 side. So we can think about this. 60 is right here, and it is 4 units away. How many is 60 away from 70, Abdu? It's 10 units, April. 60 is 10 units away from 70, right? So it's going to be much better for us to be over here on this side, next to 93. So I look at some of my answer options here. How far apart are these, 93 and 118? Sarar? At least 18. And then plus another 7, right? So we're talking 25 units away. Would you be more like 97? Would you be more like 101? What do you think? Make a choice and tell your neighbor. And maybe include a little why. Why is it 97? Why is it 101? Which one do you think? It's a fun little warm up here. Just a little brain teaser. There's really, we'll get down to a right answer. There's really no right answer just yet. What do you think, Billy? Keep going. Tell me a little more. That's exactly right. Yep. You can find about how far apart they should be. Good. So we can see that 97 is actually way too close to the number. Because the difference here, 27 and 54, that's a difference of about 25 again. So if these are going up at 25 every time, we know that the distance has got to be more than just 5. 93 to 97 is just 5 units. We need to cover 25 units, so it needs to be a bigger number, more like 101. Good call. That was a little warm up, a little brain teaser there to get you started. That one's free. Now let's get into the good stuff. Look at number 2. Let's look at number 2. What's the name this function? Ariana, since you're brand new into the class, what's this kind of function called? Yep. It's shaped like a V. Perfect. Absolute value function. We know it's an absolute value function because in all of the answer choices, they give us the absolute value bars. Those bars tell us that everything inside of that grouping is now positive. It's much, much stronger than parentheses. These bars are like prisons, way stronger than the parentheses. All right. All of our functions have an origin. However, this function does not have an origin. How many units has it been shifted over, Gerardo? 2 to the right and 1 up. Very good. So this movement, 2 to the right, is on the x side. We went to positive 2. So what should show up in my grouping? Yeah, why don't you Good, very good. So if I went to positive 2 on my graph, negative 2 will need to show up in my grouping. Remember, whenever you're inside the grouping, the signs flip. That happens with every single graph we've done this year. Every time you move to the right, it's going to show up opposite. What about this last one, though? Is this supposed to be the same sign or the flip sign? Same sign. So what would your answer be here, Brandon? Yeah, this would have to be h. X minus 2 to get it over to the right side, and then plus 1 to get it to shift up 1 unit. All right, it's time for the Inspire. You're going to want to take out your calculator. On the common assessment, and this is how the common assessment is written. It looks like this. Use the linear regression feature of your graphing calculator to determine which equation best describes the relationships, blah, 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 blah. Nobody cares about that. All we need to do is take our coordinate points and put them into our data table. We're not used to seeing our data table written out like coordinate points, but that's all it is. So while you're typing your stuff into the regression, I'm going to be making my t-chart over here of how it normally looks with our numbers. So you can go to add a spreadsheet, list and spreadsheet from the home menu. Every single person needs to be practicing this. Make sure that you put the x and y at the top of your columns, okay? Don't make your numbers come out. All right. Once you get your numbers to pop up. Oh yeah, option 3, linear regression, right? So that's what the problem says. Make your selection, and then we'll check each other's work. You want your regression to come out with all of your numbers in column C. Check your neighbor, please, so that we can move on. I want to make sure that you and the person next to you has the answer or is able to get to it. If you're having a calculator issue, let them know, and so that they can help you through it. No, that's yeah. Thanks, man. That was awesome. All right, Ariana, what'd you come out with? I'm sorry, there's 4 letters. Which one? Yeah, that sounds awesome. Esmeralda, what letter does that match up with? Cool. So we're going to choose A for that one. Great job, ladies. Let's go on now to number 4. We just went through the big 3. Regression. They will ask you regression on your final exam, for sure. You'll be doing linear regression, which is what we just did, and it's going to ask for it by name. They'll also ask you for quadratic regression. That's this one. Quadratics are different than linears. Linears are straight lines. Quadratics are the curved lines. We've only got 2 things going on here. They're also definitely going to go into absolute value, so we're going to get some practice solving those out here in a little bit. All right, number 4. Which of the following absolute value inequalities are represented by the graph? Skip the question. Don't look at the question. Don't look, don't look, don't look. Just look at the picture. Tell me a little bit about what you see here. What's in the picture, Ro? You got open dots. Good, Brandon. Shaded inside. Good. Something else. Critical. Yeah, it goes from -1 to +4. Good. All right. So those are my 2, what Critica just said, from -1 to +4, those are my 2 test points. I'm going to take my -1, and I'm going to put it into each of these equations to see if it's true or false. So let's do the first one. 2 times -1 is -2. -2 minus 3 is -5, but we're in the absolute value. So this will come out as +5 is less than +5. Is this true? Okay. Yes, but look, they didn't include the open circle, so let's not kill it just yet. All right. Come on to the next one. 3 minus 2 times -1.
So 3 plus 2 is 5. The absolute value of 5 is 5. Is 5 less than 5? Also not true. Let's go on to the next one. Negative 1 here. 6 times negative 1 minus 9. 6 minus 9 is negative 5. The absolute value of negative 5 is positive 5. Is 5 less than 15? Yes, that'll work for us. Now let's take a look at our last one here. Three times negative 1 minus 2 is less than 5. So this is negative 3 minus 2, the absolute value of negative 5, in other words. So is 5 less than 5? Also not true. All right. So now let's test our other point, our positive 4 up here. Let's go into positive 4. 2 times 4 minus 3. 2 times 4 is 8. 8 minus 3 is 5. Like that. So in both cases, this is telling us that 5 is less than 5 in both cases. But think about this. Did they actually include the points that we tested? Raul, did they include the points that we tested? So you're seeing closed circles here. No, they didn't include the point. That's the important feature here, guys. That's what we're missing. If it's an open circle, it's not actually this point. It's a point that's really, really close to it. That's why we use an open dot. So part 1 works. Because if you chose any point in here that's supposed to be in the solution set, like a positive 1 or like a 2, 2 times 2 is 4, 4 minus 3 is 1, and 1 is less than 5. All of the numbers inside of the set work. Is that okay? All right, you can test the next one too. If you plug in, let's say, a 2 in here, 3 minus 2 times 2, so 3 minus 4 is negative 1. Is negative 1 or positive 1, is that less than 5? Yeah, what do you think, Crystal? Is 1 less than 5? Yeah, so 3 works. Let's take a look at this one. We're going to do the same thing. We're going to put 2 in here. 6 times 2 is 12. 12 minus 9 is 3. Is 3 less than 15? Absolutely, that works. Let's try one more. Let's put 2 in here. 3 times 2 is 6. 6 minus 2 is 4. Is 4 less than 5? Yeah. Hey, pardon? Yeah, as long as it's on the inside of the set, and that's what this equation says. You're right. Yeah, we couldn't pick 6, because 6 would be out, and we'd be looking for like a false at that point. We'll come back to this, okay? I'm going to start off to the sides, and then put the second period on here, so that we come back to this. All right, we got a griddable. You remember these from your STAR tests? We're going to get into griddables for your May exam as well. A rainstorm begins with a light rain. It increases in intensity before decreasing again. Okay, I do not know anything about this problem. All I know is that when I look at this equation, I see what kind of symbols in there, Vanch? Help me out, Esmeralda. Yeah, these are absolute value symbols. So I have to be looking at something like a V kind of shape, which is the exact same absolute value graph we have up here. So the rainstorm begins with a light rain. And then, like we saw this morning, randomly, it starts getting ridiculous. And then we're right up here at the vertex where I guess all of us were probably on the freeway this morning. And then it started to come back down. So here's like where school starts or whatever. So we literally just saw this in real life. And they're giving us this equation to model it, where t is time since the storm began. So t is time, and this is rain. And now they're asking us for the maximum rainfall rate. How would we find that? How do you find this point right up here? Oh my goodness, you guys are freaking me out right now. Really freaking me out, guys. This is basic. Look back up here at the graph. What happened when we needed to move the vertex? It showed up in the equation. Why do you think they would give you an equation here and then ask you about the vertex? So that you could spit it back out to them. Okay. So what does this -5 represent, Luis? It goes to the right 5 units. So this out here would have to be 5. Good. We went to the right 5 units. What does this +10 tell you, Raul? We go up 10 units. So this up here has to be 10. This means my vertex should probably be something like 5, 10. All right. Now that we know that, it says, what is the maximum rainfall rate? Which one is rainfall rate, R or T? Yeah, this one's going to be R. It says it right here, the rainfall rate R. So we're looking for the Y value. Is that 5 or 10, Fevin? Okay, so we're going to list all of our coordinate points as x, y. So this means that 5 matches up with the x variable, and 10 matches up with a y variable, like a coordinate point. So when we are looking in our equation, the x variable matches up with t, and the y variable matches up with r. So what would be the maximum rainfall rate here, Fabian? 10. Good. So, and what's the units on that? Yeah, millimeters per hour. So we put 10 millimeters per hour. And this is what you would put in your griddable. You would write in the number 10, and then if they had you put the, write the units off to this side. Is usually what they do. Cool. All right, guys. That kind of takes us through our warm-up this morning. Here's the agenda for today. Oh, I didn't write it off. Oh, yeah. So we're going to do another, we started at 7:45. At 8:30, we're going to be done with this review. Then, so that's like 45 minutes of us playing together. Then we've got 30 minutes of a quiz. Then we're going to trading grade, and then we'll be out of here for the day. Okay? What we don't finish today with our packet will turn into our homework. So we're going to try to get through as much as we can in this review before you take your quiz. All right? The Wednesday right here, when you come back, that's a flex day, and because the other classes don't have it, I will probably make up like a Jeopardy game or something fun for us to do where we can use the trash ball that Mr. Oviedo nicely left for us. And then we'll come back here on the 8th and 9th, and again, we'll do one more quiz on that material. That'll be chapters 3 and 4. Then the next week we'll start our common assessments. Okay? All right. Sorry, I know. It's tough news this early in the morning. We got 20 minutes left. Okay. Hey, I've got a question. I have absolutely no idea how to solve absolute values. So, what can I do here? Kevin? Yeah, just substitute these in. So, let's take a look. We're going to do 6 and then x. Are you okay, Luis? Question? Okay, let me know. Alrighty, so the x is going to get replaced with -3 over 13, like that. Yeah, you should not be doing anything on pencil and paper. This should all be buttons on a calculator. If you find your brain getting super taxed during this, or like your brain's starting to hurt, you're doing it wrong. This should all be calculator stuff, and it should just be like texting. No. So again, those of you who failed to bring your calculators today, I'm working it out on the board for you so that you can, it's the long way, obviously. Everybody will have the answer before you, but at least you'll be able to solve it. So I solved the first half of it, and I got -1/3, and there's only one answer option with -1/3. So hopefully B came out for you. Dadgummit. Did y'all get C or did y'all get B? You need a little more work on absolute value? Okay. Again, those of you who failed to bring your calculators, look up here and make sure you're getting down everything in the pink sticky notes. This is how you solve it out without the use of a calculator. Cool. Oh, I see. Okay. So yeah, we do get 3/13, and we also get -1/3. Please give me a quick thumbs up if you got one of these answers here. Cool. Thank you. If you are one of the people with your thumbs up, please turn to your neighbor right now and let your neighbor know how you did it. We need to everybody get to this one over here, okay? Transfer to this one.
I need Raul and Evan. They're supposed to start testing.
Did I? Is that okay? Raul, can I see you real quick? That's going to be our regular. Once you take that home. Oh, worry about the other homework. Remember that I'm going to record that on YouTube so you can check it later. All right. Juan Fortozo, please come through and articulate what we just went through. What's going on in this problem?
we're going to solve the absolute value. When you have absolute values, remember that you're going to have one side. When you go to, break the absolute value signs, see these little bars right here? If I want to get it out of prison, remember that I'm going to have one side that's positive and one side that is negative. And then we're going to solve through. So when I solve through over here, I got a negative answer. The reason why it can't be that negative answer is because what that would mean is that coming out of an absolute value, you had something out of an absolute value that was negative. Is that possible? And that's why we can't use that answer. But on the other side, when we do the positive and the negative slopes, when we do the negative slope and we solve it out, it comes out to be positive 3 over 13. And that's why that changes. So in the beginning, we could have actually gone through and crossed out A, because x cannot be negative in this situation. It's an absolute value. So what comes out of this side has to be positive. X over here can also not be negative. X over here cannot be negative. We actually didn't need to do any math on this at all. No solving, no button pushing, no nothing. If you knew your absolute value rules, you could see, okay, there's no possible way that this expression would come out negative. It's an absolute value. It has to be positive. So none of these work for us. This is the only one. Off to the side, I might write off a little note to yourself here, something along the lines of absolute value answers are usually positive. That's a really good test strategy to have in your bank to save you all of that time on the test. And to your question, it's because of this. The slope on this part of the line is positive. So we first solve the absolute value function for a positive 33x. And then the slope on this absolute value line is negative. So we use a negative 33x. Cool. All right, guys. Number 7, the absolute value. Oh, it's one of the verbal ones. Do you have to strike and write? Okay. The absolute value. What does the absolute value symbols look like? Show me with your arms real quick. Okay, everybody's got it. Good. Thank you. Absolute value. Write your absolute value signs. The difference. What are we talking about when we Stop. It's not that kind of grouping. Tell me, what is difference? What operation are we talking about with difference? Crystal, when we say difference, what operation is that? Subtraction. Difference is subtraction. How would you write half x, Scarlett? It says half of a number x. How do you write that? It's that straightforward. No need to. Yep, good. 1 over 2 times x minus. And then what should come after the minus sign, everybody? Yeah, it's the next thing up in our list here. And 11. So 11 goes away. And what's the next thing I write here, Grimaldo? Cool. So just write equals 6. Your paper should have the entire first line marked out now because you've used every single thing. It should all be crossed out. Which values satisfy the statement? So we can solve it out or we can just substitute in. What is half of 10? 5 minus 1 is what? 4. Does 4 equal 6? No. So J is no good. That's just our thought for now. We're working towards it. Okay. G, half of 34. What's half of 34?
17. 17 minus 11 is 6. Cool. Scarlett, come back to 10. Tell me again. What's your thought? On 10, when I put 10 in here. So we think this works too? Okay, are we okay with 10 and 34? All right, so some people say yes on 10, some people say no on 10. Yeah, let's figure it out. Talk to each other, figure it out. Well, we know it's between G and J. It's going to be one of those two. Crystal, do you have something? You have something? All right, guys, let's come back together. We're going to share out our findings on part 7, number 7. So, Scarlett, does 34 work here for us? Yes. Yeah, 17 minus 11, that's pretty straightforward. 17 minus 11 is 6. 6 equals 6. We're good. Everybody's good on that. Now, Crystal, tell me a little bit about x equals 10. Why is this still okay for us? Awesome. So half of 10 is 5, and 5 minus 11 is negative 6. And fortunately, we're inside of these absolute value bars, which means what, Gerardo? That this is actually positive 6, and positive 6 does equal positive 6. So we can take J as our final answer. All right, couple more minutes. All right, take a look at the graph. Again, don't read the question too hard right now. Just look at the graph. We've got a baseball card on the title. We've got time in years and the value. So just looking at the graph, what do you think is going on, Luis? Like without even touching the problem, what's going on? You're right. David, help him out. Absolutely. And it's not just the dollars that increase, the value of what is increasing. What are we actually talking about? What's in the problem? Yeah. So we're hanging on to baseball cards, and over time, the bigger the time gets, the bigger the dollars get. Do y'all see that in the picture? Yep. At time 0, so when I first bought the card, how much is it worth? $6. $6. I held on to the card for 9 years. At 9 years, how much is it worth? Oh, so how much have I made then, Ariana? How much money have I made? I made $6 over time, just by hanging on to a piece of paper. Made $6. All right. So it appreciates, let's see here, if I went and I made $6 and it took me 9 years to make those $6, that means rise over run, I've got 6 over 9, which is 2 over 3. And I think the way that David explained it was exactly right, because it's rise over run. So the value per year is what this is talking about. $2 of value per every 3 years. That's what the power of slope tells you. It gives you, just like in chemistry, it gives you the units along with your numbers, so you know what's going on with your rate. $2 every 3 years. So is it C? No. What is it? What should it be then? Belia? Yeah, it appreciates $2 every 3 years. Good. All right. All right, come on over with our last question. Number 12. Is this positive, negative, no correlation, strong, weak? What's going on in this one, Kritika? This is negative correlation. How do you know that this is negative correlation, though, Juan? Yeah, is this a strong or weak negative correlation bunch? It's pretty strong, right? It's almost in a it's almost in a straight line. If it was weak, there would be a whole lot more spread to it. You know, the dots would look almost like a circle kind of shape. But this is very, very strong. It's almost an exact straight line. And the straighter line that it gets, the stronger that it is. So we would say that this is definitely a nice, strong negative correlation here. All right. Let's take a look, since the absolute values weren't going our way earlier this morning. This will be our last one, and then we'll start our quizzes. Let's take a look at number 11. We want to solve out some of these absolute value functions. You'll want your separate sheet of paper here so that you can spread out a little bit. I'm going to use my stickies so that the folks who are on YouTube can see what I'm doing. All right. So we've got 4 times 1 minus 1/3 x equals a positive 12 plus 4x. And then that's the positive side. Now we're going to do the negative side. You okay, bro? All right. We've got 4 times 1 minus 1/3 x equals, and now here's the negative side. Look what happens. This was a positive side, and I didn't change any of the signs. So on the negative sign, all of this is going to be negative. So this will be a negative 12. This will be a negative 4x. Everything has to switch its signs. And now we're ready to solve out normal algebra. Distribute your 4. Keep going across. All right, and now we can bring everything down to cancel what cancels. 4 minus 12 is negative 8. Negative 4/3 of something and positive 4/3 of something cancel. Positive 12 and negative 12 So we have 4 and 4/3 x on this side. Now we get to do our other problem. We have a positive 12 and a positive 12. So that gives us 24. Negative 4/3 and positive 4/3 cancels. Negative 12 and positive 12 cancel. And we're left with negative 4 and 4/3 x. We're almost ready. How would you use this as an improper fraction, Sarah? (16 over 3x), good. How do you get rid of this fraction in front of your x, Luis? Yeah, how could I get rid of that fraction? What would I have to multiply this side by to get rid of that fraction? To make it go to 1. Yes. What's that called? It starts with an R? Perfect. We need to multiply by the reciprocal. What is the reciprocal of 16 over 3, sorry? 3 over 16. So we're going to multiply both sides by 3 over 16 to make our fraction go away. Okay. So 3 divided by 3 is 1. 16 divided by 16 is 1. All of those fractions go away, and we're left with x. All right, now the fun part. We have negative 8 divided by 16.
Pardon the interruption.
Yes.
Teachers, attendance is still down.
Yes.
You will be receiving ABA attendance. Please take it now and then send it down to the front office with the student.
Ooh.
Thank you. Silent hallways. We're testing.
It's going to be a great day, y'all. This is going to be awesome. You're going to love it. Okay. Holy moly. All right. 8 divided by 16. What does that fraction reduce down to, Billion? 8 over 16. 1/2. All right. So that is 1 on the top and 2 on the bottom. And then that means your 8 and your 16 go away. What's the only number that you're left with? 3. So 3 on the top, 2 on the bottom, with a negative sign. That's your final answer. Okay. Now I did that one for us so that we could get a little bit better practice on the other side. This fraction right here, it's going to be the same exact fraction, right? So 16 over 3. How do I get rid of this fraction in the front, Andrew? I need to do what operation? What operation? I can take the reciprocal, and how do I do that? Okay, and then what would I do with it? I need to multiply the reciprocal on both sides. Cool, thank you for that full thought. All right, negative 16 over 3 is going to turn into negative 3 over 16 to cancel that out. And then the same thing on the other side, negative 3 over 16. All right. That goes away to 1, and we're just left with x. And now let's pick up the pieces on the other side. 24 and 16. 24 can split, can factor into 3 times 8. And 18 can split into 2 times 8. So because I have an 8 on the top and an 8 on the bottom, they can go away. And I'm left on the top with negative 3 times positive 3. What's negative 3 times positive 3, Crystal? Close. What's negative 3 times positive 3, Ariana? Close. What's negative 3 times positive 3, Vanch? Good. Negative 9. And then on the bottom, we're going to have this 2. Okay. All right, guys. That is our time for review. Yes, ma'am. It sounded a little funky. Yeah. So this should be 4, 4, and 12 is 16. So this would go away, and you just be left with negative 3. Is that what we're saying? So this answer would actually be negative 4 times 1 is 4. 4 plus 12 is 16. 16 is divided by 16 is 1. So the only thing we do left is all right, guys. We're going to do testing folders here in a little bit. Go ahead and get set up for our quiz we just reviewed. All right, guys, if your table is missing some testing folders, please grab some from the very back. Just send one person up, and make sure you've got your calculator and your pencil ready. We're going to get started here just in a second. All right, guys, here's the first section. It's going to take you about 10, maybe 15 minutes tops, and then I'll give you the second part of the quiz just as soon as you're done with this one. It's going to be the same deal. It's like 15 minutes. Make sure you got your calculator out because you're going to just immediately start the regression. You know that they're going to ask you that on all the exams here. All right, guys, make sure your name's at the top. Put your class period off to the side if you would, please. That'll really help out. Just put class period 2 off there.